right, and welcome everyone. I'm Philippe Ombredanne, I'm the CTO of nexB, and today I want to present the latest version of VulnerableCode, version 31, and also present you not only the features, but the demonstration and our plans for next and future versions. So, what are we talking about today? Talking about vulnerability database, meaning a database of known software bugs that have a security impact. And today, most of these vulnerabilities, vulnerability database are proprietary, and or if they're not proprietary, they are essentially privately maintained. And you know, we're talking about security bugs for open source packages, and why not open data after all? Open source likes to be open, right? So I'm going to present what we do with VulnerableCode, and what we do is aggregate and publish not only software but also open data that we collect from multiple data sources, such that you can automate the search for known vulnerabilities, which is a major issue. And that's an easy, low-hanging fruit in a way, compared to many other security remediation actions you could take to secure your software environment. Not using known vulnerable package is really the essence of avoiding problems. And we believe that by using a better database of open source vulnerabilities, that's both open code and open data, everybody will benefit. In a way, you could think of security information as being oxygen for the internet. It's if you know and you can remediate on these issues, that the internet continues to run. And we want to make sure that there's no tax and impairment to access this data for everyone. So we very modestly may help a bit to let and keep the internet running. So, agenda for today. We're going to look at the problems, the gist of our solution very quickly. We will look at the demonstration. You may or may not know what was in the previous version of VulnerableCode. So I'm going to go also in what we have today. And we'll discuss a bit about the next steps. So software supply chain security, obviously, it's a huge topic. If you're in any kind of sizable organization, commercial, non-profit, governmental, you probably had a team that was going through a mad dash last year, about 13, 14 months ago in December and January, about Log4j, which is a Java library for logging, which had a major vulnerability, which is an open source package. Linux Foundation has a sub-foundation called the Open Source Security Foundation, and they've identified multiple focus areas for improving the security of software supply chain. The focus we have on our side is modestly trying to find and more easily remediate on security vulnerability, so security bugs. And we do that with what we call SCA, so Software Composition Analysis, which is a combination of code and data, which we provide as free and open source software and open data, again, with a goal for us to improve modestly, potentially, the whole security of the internet, and very specifically of your organization. So the problem is that there is no open code and open data vulnerability database that provides quality data today. Most of these are essentially proprietary and commercial. And maybe I'm cynical, but I think that vendors in the space, they do not want to solve the problem. They're happy somehow that This is a complicated and complex topic and domain. And the more fear and uncertainty there is in the space, the more they have selling arguments, selling points. It's sad, as I said, we're talking about oxygen here, and I really wouldn't want to have a tax on oxygen, but one of their key arguments is they have the biggest database. You know, there's a, like, bigger is better, but that's not true. You end up having both expensive and poor quality at the same time. And we'll come to some examples in a minute. There's a number of attempts to do free database. The problem is that most of the time today, they're problematic because there's an opaque review process. So we don't know how they came to justify this vulnerability or this score. So there's a lack of transparency, which is really important for security matters. And overall, there's a poor data quality. When I say poor, it's like, it's really messy. We have databases that make up packages that do not exist. They're saying, oh, package foobar is vulnerable to these vulnerabilities, but package foobar doesn't exist. So you would say, it's not a big deal, the package doesn't exist, no one will use it, and therefore it impacts nobody. But this is something that really shatters confidence you may have in the data. In some cases, we've seen databases that invent vulnerable ranges, and in others, we see cases where they do not agree on vulnerable range. If I'm a security team on the receiving end, and given a package and a bunch of versions of this package, database 1 says, oh, version 1 is vulnerable, but not 2, and database 2 say version 1 and 2 are vulnerables, but not 3. I'm left with my eyes to cry, and I'm scratching my head. What is the version that's vulnerable? Each time I have to do this kind of soul searching to figure out what's the vulnerable range. It means extra work, potentially working on in some case, dubious vulnerabilities, which shouldn't even exist because they're contentious and not considered by most as a vulnerability. This is wasting time. Each time you're wasting time, you're leaving the advantage to the bad guys, basically. Many of these databases, the proprietary ones, they claim to have like the secret premium vulnerabilities. And again, going back to our first stance and approach coming in, having secret vulnerabilities in a way, it's not much different from somebody that will sell exploit on the dark web. You're basically leveraging information about security of open source code that only you know. The dark web bad actors sell that for exploit. You're selling that for profit, but essentially it's the same. You're putting a tax on vulnerabilities, and of course in this case they do not publish their finding in shared database like the nationality database. So it's a real problematic environment and segment and market, unfortunately. And you know, in a security team, what I would expect is that I have a tidy and organized security gate. It can be messy. There may be a lot of vulnerabilities to triage, but at least there's some organization. But really what happens is this. It's a total mess. And the folks that are dealing with remediation and keeping running large and complex systems in your organization and on the internet are struggling in front of the mass of dubious, incorrect, false positive vulnerabilities they have to triage and somehow process, because you really don't know until you've processed it in details. And as a result, of course, we've seen several large vulnerabilities that were impacting, in some case, open source package, but not only. SolarWinds was another issue the year before. And we're likely to see more of these. Hopefully, we'll be able to help, again, in a modest way to get rid of some of these issues. So, our solution. How can we tackle this problem? And I'm pretty sure we all agree there's a problem there. The way we do it is, on the surface, very simply, a database, which has a web UI and an API, and a command line, plus a tool called VulnerableCode. We're going to see these in the details in a few minutes. And how we get there is we collect the data from many data sources, and we merge and combine them in a clean data set, and we import these as much as possible from upstream. Upstream meaning going straight to the source of the project that provides this. As an example, we collect information directly from OpenSSL rather than getting it secondhand from another database. We collect information directly from Nginx. And it's not easy. For instance, the contributor that worked on importing the Nginx data had to spend about 2 months of email exchanges with the Nginx maintainers and developers and creators to make sure we could understand exactly what they meant in the published security advisories they were providing, which were not entirely clear. Hopefully, this is something that will help everyone. The other thing that's important is that we're working on what's called Perl or package URL, meaning it's not so much a vulnerability database, in as much it is a database of packages, and we know which vulnerability applies. It sounds minor, but it's fundamental, and it's completely different from what's been done before, where most of the database were about vulnerabilities first. If you care about vulnerability first, it's a bit like you have a freestanding bug, but you would not know what's the piece of code that it impacts, which is obviously not exactly the best case to streamline and automate how you could fix the issue. We also track all the license of the data we collect. I'm surprised that we had to contact the Debian team that deals and publish security advisories to ask them for a license because they didn't have one. The same for Ubuntu. So that's great. Now they have one, but we had to contact them. So I wonder if anyone has ever used and or worried about ensuring they were getting clean license for security data. We are also deployed something where we can have smart vulnerable version ranges. It's a spec that we created as part of the package URL specification, and a library that we call Universe for universal versions. We're very proud. It's also used in a Google project called OSV. So if they reuse some of our code, we probably must be onto something not too bad. And last, importantly, is we have bots that are scouting the database and in some case going outside to improve and refine the data. For instance, if there's a package, we want to make sure the package exists. So we avoid the problem of having non-existing packages in the first place. So I'd like now maybe to show you some of the issues we were talking about. So for instance, this is an example in a database for vulnerabilities from a company called Snyk. We're using public information just on only things that were published on the web. And you can see that for a given package, that's a package URL from Python and Django, this version, we've been querying a bunch of database, and we see that they, on the one hand, say we have all the versions below, but we have also conflicting ranges where it says before, after, and includes. Basically, in the end, you don't know whether the range applies to all the versions or only some of the version. You see here and here how the two conflicts. It's a problem, of course, because you're just scratching your head then which is the version that is really impacted. Any kind of confusion is a source of problems. Another example, this one from GitHub, and I'm not picking on GitHub or Snyk. I'm just saying that universally we have this kind of problems. We happen to find them in VulnerableCode because we're aggregating data and we have tools to validate the data. And I'm saying we're trying to fix the issue. The problem exists, and that's why we have VulnerableCode there in the first place. This example here, we have a Java client, HTTP client component from Apache, where GitHub is reporting all the versions below 4.3.5 as vulnerable, but they're also saying every version above 4.3 is vulnerable. And so we have something here which is fundamentally not correct. You cannot be both above and below the same version. So that's another problem. Another example here, we have junk CV, so vulnerabilities, which have been rejected by the National Vulnerability Database as being not serious ones, but they still exist in OSS Index and OSV and GitHub. So there's been work done to say, oh, this is not a real vulnerability, but again, in the race of having more and having bigger stuff, you end up having database that promote dubious problems. In some cases, it's a bit more subtle. This is a bolt-on published by Apache Tomcat that we integrate also in VulnerableCode. Again, we're trying to go upstream. And they say, we have here this issue that's fixed in version 7.0.8.8, but it also affects version 0.8.8. And you could say, no, it's excluding the boundaries. Actually, no. Every range otherwise in their vulnerable definitions and security bolt-ons are from including version to including version. So again, I was talking about things that are made up. This vulnerability on GitHub is about a package that's written in Go. This is the package here. And you can find it here. It's 99.99% Go language. Yet, they also report something about a NuGet package. You could go on NuGet, it doesn't exist, right? It's not a NuGet package. It's something they've made up. They've made a version range that don't exist. So it's not a big deal, as I said earlier on. If it doesn't exist, nobody will use it. But the problem is this. It's something that's a high severity issue that's been GitHub reviewed. It was updated, so meaning likely reviewed again last week. That's confidence shattering when I see this kind of stuff. I'd rather see something which says, oh, this is a work in progress, it's not been reviewed. But if it's been reviewed, I'm assuming maybe naively that there's a human that's a security expert and there's been tools that have been running and applied to make sure the things are correct. And that's not the case. Here we have another impossible situation where we have conflicting ranges. So just to give you an idea of all the issues we're facing, it's all over the map, and we're trying modestly to fix some of them. And that's the essence of vulnerable code. So now, I'm going to go actually, before showing you the new things, first in the demonstration. So vulnerable code, what does it look like? This is a public instance, so that's how you go in. There's a web UI. You also have a JSON API. And you can search for package or vulnerability. So if you search for log4j, for instance, you could search by package URL, but then you can see everything, even if you search by keyword, ends up being keyed by package URL. And you can drill down. You have summary of vulnerabilities and their aliases to outside references, and you can further dive, get information about scorings, and you see how we have another issue. That's something we want to tackle next, but you have one vulnerability and multiple reputed actors. We're talking about Red Hat, the National Vulnerability Database, and GitHub are providing conflicting scoring about the severity of this vulnerability. You know, is this critical? Is this medium? Is this moderate? Is this 8.1 or 9? It's difficult because maybe some of this scoring applies to a certain context, but when you collect this information, you would hope that there's eventually some consensus and convergence of opinions on whether this is critical, medium, or moderate. As on the receiving end, as a security analyst, I need to triage the mass of vulnerabilities. If I don't have a score that I can rely on, that's reliable, I have to redo the work, and eventually even the most modest vulnerability becomes something that's going to take of my time. And it's really important, because if this is not critical and this is really medium, then maybe I will waste my time remediating this issue instead of addressing the other one that's critical, that may be exploited and exploitable by the bad guys. All right, so that's the gist of it. You can navigate, find packages, and there's distro packages, application packages. We track both which are the versions that are affected, and also which are the versions that are fixing a security issue, and a lot of references in the case of very popular vulnerabilities like the one that affected Log4j. These are, there's a lot of them, of course. That's the essence of what you get there. The other thing that's interesting is a tool called VulnTotal. If I were, for instance, to take this here package URL, so I'm going to copy that, and I'm going to the command line here. I'm making that a bit bigger. And I'm going to run VulnTotal and pass it the package URL I want VulnTotal to check. And what's going to happen there, I didn't configure everything. But what it's doing is that it's calling VulnerableCode, Snyk, GitLab, OSS, Index, OSV, devs.dev, and other data sources, and telling me, hey, this is the set of vulnerable packages, this is the set of fixed packages. And you can see that, you know, for instance, these two databases don't seem to agree on the ranges. It's really problematic. We don't have, in most cases today, for the same vulnerability, the same vulnerable ranges. So what this means then is that you're really left with your eyes to cry. It's compounding the problem we're reporting earlier. We don't have yet a perfect solution, but at least being able to take good grasp of the problem, I think, is really key. So we've seen two of the main features there. Let's go and discuss a bit what's new. So the first thing is we have a web UI. Well, you've seen that. It's new to you, but it's also new to us. We had only a JSON API before, and of course that makes a lot of the difference. We also have a fairly nice and growing documentation, which explains how to install it locally, how to use it, how to extend it. It's growing, it's not perfect there, but the difference between something which is just code dumped on a Git repository and something that's usable is the documentation. So we're putting a lot of emphasis to ensure we get a better documentation so it helps you as a user run it more efficiently. We've made, so this public instance that you just used that you can access right now, it's throttled, so we have API access and you can sign up for the API very simply here. Just provide an email, and if you need to do some large-scale evaluation, you just send us an email and we'll remove the limitation on the throttling for the API. It's a shared resource. We just don't want that to be wasted if there's someone that by mistakes just creates a denial distributed service attack on the site in question. We can do now faster API search with a bulk capability, meaning you can feed many package URLs. We've looked at VulnerableCode briefly. I'll come back to it in a second. Think of it as a vulnerability database comparison shopping. It goes and compares GitHub, GitLab, Snyk, OSS Index, VulnerableCode, and eventually more database, and tells you what they report for Perl. We've also entirely reworked the internals. That's less visible for you as a user. It's important for us because it's going to enable us to iterate faster on new features in the next few releases. We had a certain level of technical depth there to clean up. One important thing is we've adopted a new spec that we wrote and designed as part of the package URL, which is the version range specification, which helps us store range of vulnerable versions in a simple single string, a bit like a package URL, but for versions. We also re-enabled and refined, improved many of the data importers we have. So you have the list there. We had to temporarily disable some of them in the past before, as we were doing the migration to this new internal model. We even have a version 32, which is coming up right after this. So on the heels of 31, we're already now working on this 32. We enabled more importers. We've completed essentially the migration of all the importers. We also added support for CWE. CWE stands for Command Weakness Enumeration. It's a way to categorize the type of vulnerability and the type of exploit and security issues that is behind the vulnerability. We have also improved handling of the scores, and we discussed about the license of data. So we will have in version 32 proper license information for all the importers. As I said, we worked in many cases with upstream security teams in Linux distros, in package management environment, to ensure that we could get proper license. I'm worried for all the commercial actors out there, which may reuse some of the same data we do, except that they were not really licensed for that. Anyway, so that's community service also for them. Clear licensing for everyone when you reuse somebody else's data. Now, let's go back a bit on VulnerableCode. You know, it's all talk on my side to say, yeah, you're going to do something that's better, blah, blah, blah. Nice chat, a small violin, blah, blah, blah. But can I prove that this is better? And, you know, somebody said, in God we trust, everybody else bring data. And what we did with VulnerableCode is exactly that. The idea is to say it's comparison shopping for vulnerability database. So I took a mock-up of Google's shopping, and I did some edits here to say we have shopping for CVEs for Log4j. The point is, what it does, it goes in all of these databases, retrieves the results, and show them side by side. We're going to improve that, but it's a way to prove that we are as good, in some cases better than others. There's an early adopter of VulnerableCode that recently made a test. It's a fairly large organization. They have like, they use about 40,000 different packages internally. So what they did is they took the list of 40,000 pearls. They used the commercial service that they have today to check them for vulnerabilities one by one. They did the same in VulnerableCode, and they compared the two together. And they came back to us saying, hey, you know, that's pretty darn good. We like what we see. You're at least as good. Oh, there's this area, by the way, I don't know why, but you don't have any vulnerabilities about NPM and JavaScript. And of course, the explanation is that when they were doing this test a month or two ago, we hadn't yet re-enabled and remigrated the code to collect JavaScript vulnerabilities. So that was after that something we were able to clarify and change. But the point is, it starts to be pretty good. The other thing that's interesting, I'm going to go to somebody called Steve Springett here. Steve Springett is one of the leaders for the OWASP project, which means Open Web Application Security Project. He's also behind the Cyclone DX SBOM standard and the dependency track tool for security and managing and tracking security in packages. He's big about package URL. He was publishing a couple of months ago, together with a group of others, an open letter to the National Vulnerability Database to say, hey, you guys should use package URL. I was psyched. That's awesome. Because package URL is something that we started and that was created by yours truly to support VulnerableCode and scan code. And it emerges today as the critical glue between all these software supply chain tools, because it's a simple intrinsic identifier that a tool can use to communicate with another tool. In our case, if you think about the workflow, generally speaking, it's fairly simple. You scan for packages, you need a package URL, then you can look up in VulnerableCode. Well, scan for package, you can do it with scan code, but you can do it with a large number of other tools that today support package URLs, both as input and an output, meaning it really enables workflows, integrations, and pipelines, which were impossible just a few months ago because you didn't have this kind of a glue identifier between all the tools and the data they use. So being able to do that is really super important. So the workflow, that's what we've gone through the demo. Package URL, as I said, super essential things. It's used pretty much in every software composition analysis tool today, be it open source or commercial. It's the key, the growing key for vulnerability database, which means that eventually, even for us, it makes things simple to combine, merge, and refine the data based on this identifier. And we're very proud that, again, that's something we started for scan code and vulnerable code, and that it gets so much adoption everywhere. Okay, now the problem is that we've created this database, and if I aggregate this data in a central database called VulnerableCode, I'm probably doing something wrong. The same way everybody else was doing something wrong before me, and I cannot be the only one to control the data. If I'm doing that, I'm adopting the same flawed ways. So we're working next on making this a shared resource for everyone. So shared resource for everyone means we want to participate, be eventually an anchor to make this ecosystem work for everyone. But we want this to be a shared control, shared resource under everybody's control, not only our own control. So you can already self-host VulnerableCode entirely, locally, no strings attached, no phone home. You can run it air-gapped on premise. We're working next to have a new way to federate and decentralize and share the data, not only to share the data, but also to share the review of that data. The big problem when you see wrong ranges in non-existing package and all the data quality we have, we're going to need to crowdsource and bring together a bunch of willing security experts that can help curate and share back this information for everyone to benefit. Which leads us to our next steps. One of the big things is going to be collecting what we call the fix commits. Whenever you have a package that is fixing a bug, a security bug, a version of a package that fixes a security bug, we want to collect which commit did this fix, commit or commits. So it could be a patch in some case. The reason behind that is that you could then use tools like Eclipse Steady, for instance, for Java and Python, and there's other tools that likely could emerge to analyze the call graph and determine, does my usage of this library or code go through the vulnerable path? Is the vulnerable code used in the first place? And that could be done with a static analysis or dynamic analysis. As an example, you could check if you have a decent test suite and running a line level coverage, whether your tests actually exercise any of the code that's in the fix or the code before the fix that was vulnerable. All these are essential because that's the way to provide hints to security teams so they don't have to go through the manual triage. If you can tell them ahead of time, oh, yes, you have 20 versions of Log4j installed in these 50 applications, but these 30 ones here, they don't use the feature that's vulnerable at all, so you're safe. That means you can do one half of the work. So it's huge. It's really huge in potential. We've seen how advisories are all over the map. And so we're working on the design of a new advisory clarity score. The idea there is we can rate the quality and the providers of the data we aggregate and import to provide a hint about their quality and eventually guide the human curation and review. We're going to make VulnTotal work as a browser extension. One thing I didn't tell about VulnTotal is that it's okay for me to use it, but it's querying open data source on the web that may not be okay to expose as part of a service. So it's a command line tool. You can run it. I cannot run it on your behalf. It probably would be a violation of the terms of service if I were to do so. But it's okay for personal use. And by making it a browser extension with zero installation required, it's going to be easier for you to run it without having any infrastructure. We're also working on smarter improvers. We talked about, simple stuff like check if a package exists, validate if the version ranges and the ranges are correct and exist, validate that they're consistent, that they don't overlap. You cannot say version 1 is vulnerable and version 1 is not vulnerable. At the same time, we've seen that it unfortunately happens. We want to be able to mine also the graph of relations we have between the packages and the vulnerabilities and the different packaging of the same package. You may have OpenSSL upstream. You may have it in Debian, Alpine, Fedora, and they may have different take on which version is vulnerable to what. And being able to match this relationship is huge because it enables to better understand when a vulnerability applies and what's its severity. There is also a lot of natural language that is an untapped mine of information in the description and summary of advisories. We want to apply some kind of natural language parsing. I know it's been done already probably by some, so we may be able to reuse some code there. We want also to be able to extract unpublished vulnerabilities from the commit histories and trackers. The barrier to submit a new vulnerability to the National Vulnerability Database, for instance, is somewhat high. And therefore, there's a lot of vulnerabilities that go unpublished, unnoticed. The bad guys, the bad actors are doing just this. They're mining your commit histories. They're looking at open source package trackers to figure out, is there something I could exploit? So we better do it also on our side so we can surface this information with the objective and the goal to eventually share it back. We're not trying to be the depository and sole owner of secret vulnerabilities. That we want to share that back, making sure it's available not only in VulnerableCode, but also probably in other vulnerability databases like the NVD. And if there's a barrier to entry to submit that, we'll bite the bullet and do the work as much as we can. We discussed about the need to have a way to crowdsource and federate this data, especially on the curation side. And the other thing that's interesting is this tool that's called NVDR, Non-Vulnerable Dependency Resolver. The idea is simple. You want to avoid vulnerabilities in the first place. Now, when you use packages, you are saying, hey, I have direct dependencies, so I depend on log4j 123. That's what we call functional dependencies. On the other hand, you have another range which says version 1 to 2 of log4j are vulnerable to this vulnerability. If you can merge the two set of constraints together, say you're depending on version 1 to 3 or higher, and you know that every version between 1 and 2 are vulnerables, what are you going to do? You're going to pick something which is bigger than 2, right? that's very simple, that's obvious. But it's never been done until now. And what we can do, because we have this syntax to express ranges of versions, we can combine the functional dependency constraints, the non-vulnerable range, inject this in a dependency resolver to get non-vulnerable dependency resolution. We have a working proof of concept implemented by Tushar in the Python inspector tool. And there's a paper that we've published also there. We are working to make this something that would be a universal solution. I hope in the future, eventually, that every single package management tool will have this feature. So it's going to be maybe just a teaser for now, maybe not. Ideally, as I said, every package management tool, NPM, PyPI, Bundler, the distro package should not let you install non-vulnerable package in the first place. That's just nuts. And that's pretty much it. So sustainability, this is obviously a lot of efforts. We do that just for the good of everyone. And I just want to make sure that you understand that it's a project that you must help fund. You can come with cash or sweat, both are welcomed. And we've received some grants from the European Union, so the AGI Zero program and NLNet, which is awesome, but we also need your help to make sure this is something that is sane and sustained for the long term, and that we have together a wonderful and quality security commons. And that's pretty much it. Thank you very much, and have a wonderful day.
We have a question. This one comes from Ion.
Yes.
Do you already provide the data dumps along with the code releases in v31, or is this coming up with v32?
We provided some in the past. We had several schema changes, so we are going to provide these again in v32. And they'll be available straight from GitHub here with the v32 release candidates. Well, the final release that's going to be there on v32. We're right now publishing release candidates, as you can see, for 32 RC1, which was 2 weeks ago, and 32 RC2 also 2 weeks ago. We're likely to have 1 or 2 more release candidates, and then we'll have final.